welcome to the homework help video, page 328. Let's go ahead and get started with the problems, okay? Let's take a look at numbers 1 through 4. 1 through 4. The directions say to match the name of the transformation with its diagram, okay? So here we go. Let's take a look at letter A here. Students, please notice the tree has not been flipped or turned or twisted. It simply went down to the bottom. It went down and then it went to the right. We call this a translation. So letter A goes with number 2. Translation, okay? Let's take a look now at letter B. Notice if you got a piece of paper right here and you were to fold the sheet of paper right on this line here, this object here would fall directly right on top of this object here. Okay, so we call that a reflection. Okay, anytime you can pretend that you're drawing, that your two images are on a sheet of paper, if there's a line anywhere that you can fold it over and it would land right on top of the other one, then we call that a reflection. So letter B would be here for number 1, reflection. Okay, alright, moving on to number 3. Now notice what I have here, please. Students, look. I've got a piece of watermelon here. Okay, and pretend there's a piece of string attached to it. And then, or I guess I'll say pretend that you have the piece of watermelon cradled in this thing right here. And then it's rotated like this. It's rotated down, okay? And notice how when it's rotated, it changes direction like this. And now it's facing out this way, okay? We call that a rotation. A rotation. So letter C goes with number 4. And of course here for letter D, notice how the image here is much larger than the image here. So we call this a non-rigid transformation. Non-rigid transformation. So letter D would go with number 3. Okay. Alright, moving on. Let's take a look now at numbers 5, 6, 7, and 8. The directions say to name the transformation, okay? Name the transformation. So here we go. Now please notice, students, here the car is facing the same direction, okay? And it's gone down and then over a little bit. We call that a translation. Okay, a translation. It's not been flipped, it's not been turned, it's not been rotated, okay? We call this a translation. Alright, number 6. Now, on number 6 here, if I were to draw a line right here and pretend I had these two images on a sheet of paper, if I were to fold the piece of paper right here, this image would fall directly on top of this image here, would it not? Sure it would. So we call that a rotation, or excuse me, a reflection. A reflection, okay? Now number 7, when I first glanced at it, I thought it was a reflection, but it dawned on me, if I were to pretend that these two images were on a sheet of paper and fold the sheet of paper right here, this image here would not fall directly on top of this image here. You can tell it just wouldn't. So what I have is this. I actually have a rotation. Look, now watch this, please. I took the car here. Pretend you're on a curvy road and you drive the car like this. You're going this direction, like this. If you continue rotating the car, it would then be upside down and it would be right here. Okay, that's a rotation. That is totally a rotation. Okay, well, Mr. Harris, we just moved the car down. No, you didn't. The only time you have a translation is when the car is still facing the exact same direction as it started with, okay? There's not any twisting or turning. You just move the car like here, down and then over, okay? So this is a rotation. A rotation. Now this one here, number 8, is pretty easy to see. It's a rotation. The car's here and it gets rotated upward like this. Okay, So it would be a rotation. Okay, rotation, not a reflection and not a translation. Okay. Alright, let's move on to numbers. I think we skipped a page. Yeah. Let's move on to numbers 9 through 12. Name the transformation. I love this. This is so good to practice, practice, practice. Now remember, blue is the pre-image, okay? Blue is the pre-image, so here's blue. And we went from here to here. Well, guys, notice the figure's not twisted or turned. It was just simply moved to the left. That's going to be a translation. Okay, a translation. Alright, number 10. Here's the pre-image. Okay, right here. Here's the pre-image. Like it's on a string here. And then we swing this igloo up, attached on the string here. And it would look like this. Right here. Okay, so that's going to be a rotation. Alright, a rotation. Okay, students, let's move on now to number 11. Number 11. I guess it's pretty obvious here. They actually draw the line for you. But again, if you had these two strollers drawn on a sheet of paper, and you were to fold the sheet right here, this image here, your pre-image, would fall directly on top of your image. So we have a reflection, okay? Now, number 12, notice carefully, the boy's face has not been turned at all. It's this face here is not, and this face here has not been twisted, turned, rotated, or anything. It has simply been moved up and then over to the left. So we call that a translation. A translation. Again, students listening, say, Mr. Earhart, this is a translation right here because you went up and over. No, no, I didn't. It's not facing the exact same direction. It's been twisted. Here the igloo is facing out this way, then it was facing up this way, okay? No, in order for you to have a translation, the original figure cannot be twisted or turned at all. It's just shifted over and up or over and down, okay? Alright, I hope that makes sense. Moving on to 13 through 16. The directions say to decide whether the transformation is an isometry. If it is an isometry, name the transformation. Now students, please listen to me, okay? An isometry means you have a rigid transformation, okay? A rigid transformation. So number 13. Do I have a rigid transformation? Well, no, of course not. Your pre-image is much smaller than your image. So no, this is a non-rigid transformation, or it's not a rigid transformation. However, number 14 is a rigid transformation. This shoe here, your pre-image, is the exact same size and shape as your image. So now here's where your original, remember blue is your original object, okay? Your pre-image. And notice how it looks like it's been rotated. Pretend I have a string tied to the shoe, okay? And I swung it. Let's see. Would that be a rotation? Or would it not be a rotation? You know what? The book says a rotation, but I'm having my doubts here a little bit. Let's see. I might have to take issue with the book here on this one, and I would welcome any of y'all's comments. Feel free to email me with your opinion. But students, to me, if it's rotated, just like the car back here, remember how it was rotated around and ended up being upside down? Well, this here, if you rotate this thing, it's going to end up being upside down. I would think the blade should be here. Here I go again, showing my wonderful drawing skills. And the boot part should be out here. But either way, I do not agree with this being a rotation. Well, Mr. Earhart, what is it? Well, it doesn't have to be anything. I mean, to me, It's to me, it doesn't have to be a translation, a rotation, or a reflection. Okay, but they're calling it a rotation, so that's fine. Okay, number 15. This is a rigid transformation. The pre-image and the image have the exact same shape and size. And notice it's not been flipped, twisted, or turned. It's moved down and then it's moved over. So number 15 would be a translation. And then number 16 obviously is not a rigid transformation. It's not, because this pre-image here is much bigger than the image right here. Okay, I hope that makes sense. Remember, an isometry is a rigid transformation, and the directions say decide whether you have an isometry or not. And if you do have an isometry, that means you have a rigid transformation. Okay. True or false for numbers 21 through 23. If ABC is mapped onto DEF by an isometry, then the two triangles are congruent. Now, mapped on just simply means that you've taken the triangle and you've shifted it. You've either rotated it, or you've reflected it, or you've translated it. Okay, so if ABC is either reflected or rotated or translated to triangle DEF, by what method? By an isometry. That means you have a what, students? A rigid transformation. If that happens, then the two triangles are congruent. True or false? Well, guys, of course that's true. We know it's true because a rigid transformation is an isometry. And if you have a rigid transformation, the two shapes are the same size and shape. So yes, it is true. The two triangles would be congruent. Excuse me, moving on to number 22. An isometry is a rigid transformation. Well, that's really easy. That's the exact definition. True. An isometry can map, or in other words, rotate, or reflect, or translate an acute triangle onto an obtuse triangle. Well, of course not, students. An acute triangle can never be congruent to a what triangle? Obtuse. That's impossible. An acute triangle can never be congruent to an obtuse triangle. So how could you use an isometry? The only time you can use an isometry is when your pre-image and your image are congruent. They're the exact same shape and size. So false. No, you cannot use an isometry to map an acute triangle onto an obtuse triangle. Okay, cannot be done. Okay, which letters are rigid transformation of the other letters? Well, how about B and D? B and D. They're rigid transformations. They're a reflection, are they not? Sure they are. B and D are a rigid transformation of each other. How about U and N? Here's N. Not a very good N, but here's N. Here's U. Okay, that would be a rotation if you took this N, and it would not be reflection. Students, don't be confused. If you were to put a line here and fold the piece of paper on that line, this would not fall directly onto this. It's a rotation. It's a rotation. Okay? And then there's one more. Let me see if I can find it here. Oh, Q and P, right here. They're side by side. That would be a reflection. Okay? If you were to draw a line here and pretend P and Q were on a sheet of paper, and you were to fold the sheet of paper on that line, P would fall right on top of Q. So, what letters are rigid transformation of other letters? B and D, P and Q, and N and U are rigid transformation of other letters. Okay? I hope that makes sense. Let's move on now to number 25. Numbers 25 through 30. Now this arrow here means mapped onto. So ABC is mapped onto what triangle? Well, notice ABC. So 30 blank 40. 30 blank 40. So look for a triangle. It's 30 blank 40. 30 blank 40. So H-I-G. These are really easy. Okay, triangle blank is mapped onto triangle EFT. This is EFT. So let's find EFT. Here we go. Here it is. EFT blank 4535. Blank 4535. Here it is. Blank 4535. KJL. 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 Alright. Okay, triangle LJK. 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 3545 blank. 3545 blank. Well, here it is. 3545 blank. DFE. 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 Okay. Triangle DEF. DEF is 35 blank 45. 35 blank 45 is mapped onto what triangle? Here it is. 35 blank 45. 35 blank 45. LKJ. LKJ. Alright, there it is. LKJ. Alright. What triangle is mapped onto ACB? ACB. 3040 blank. 3040 blank. 3040 blank. HGI. HGI. And then lastly, triangle CBA. CBA. 40 blank 30. 40 blank 30. 40 blank 30. GIH. GIH. Okay, so there we're just practicing seeing how you can take a triangle and map it onto another triangle by using an isometry. And what are the three types of isometries we've learned today? Reflections, translations, and rotations. Alright, let's continue on. Let's look at a couple college entrance exam questions. Now, in triangle ABC, AD bisects BAC, CD bisects BCA, if measure of angle B is 100, what is the measure of angle D right here? Now, students, please think about this. Look, pretend that this point right here started up here. Okay? ADC. And as I move this point down and keep pushing, eventually this point right here, point D, is going to fall right on top of this. Okay? So if this angle here is 100 degrees, and then if I pushed it all the way down, this angle right here would be 180 degrees, a straight line. Look, doesn't this point need to be right in the middle of 100 and 180? Sure it does. How do I know that? Because this angle is congruent to this angle, and this angle is congruent to this angle. So because of that, it only makes sense, guys, that this angle right here is 140 degrees, okay? Because this is 100 degrees here, all the way down would be 180 degrees, okay? And half of that would be 100. The midpoint between 100 and 180 is 140. And I know this is the midpoint because this angle here is congruent to this angle here, and this angle here is congruent to this angle over here. Okay? Hope that makes sense. Moving on to the last problem. This one's really, really easy. Notice I have this side here congruent to this side here. So in a triangle, when two sides are congruent, their opposite angles are congruent. So this angle here has to be congruent to this angle here. If this is 60, that means these two angles here have to add up to 120 to give me a total of 180. So if these two angles here have to add up to 120, that means this one's 60 and this one's 60. Now I have a straight line right here with a ray coming off of it. So this angle here and this angle here have to add up to 180. So this angle would be 120 degrees. Now, notice I have a triangle here in red. And whenever two sides of a triangle are congruent, their opposite angles are congruent. So that means this angle here is congruent to this angle here. Well, if this is 120, then these two angles together have to be 60 to give me a total of 180. So if these two angles together have to be 60, then this angle has to be 30, and this angle here has to be 30, okay? Now they're asking, what is the measure of angle C? Well, here's the measure of angle C right here. 30 degrees. 30, okay? I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.